Hello everyone, welcome to MedDevice. In this video we're going to be studying the carbon dioxide transport. So let's start. So carbon dioxide is transported mainly in two forms, plasma or in the RBC. So again in the plasma there are three forms and in the RBC there are three forms. So the carbon dioxide that is dissolved in the plasma is 5%. The carbon dioxide that forms carb amino compound is 1%. Bicarbonate is 5%. It's not important to remember all of these percentages. This is just to give you an idea of how the carbon dioxide is transported. Now in the RBC, the carbon dioxide that is dissolved is also 5%, carb amino compound is 21%, but the most important one that you have to remember is that the main mode of transport of carbon dioxide is bicarbonate in the RBC. This is 63%. Now let's see the carbon dioxide content and the partial pressure in the arterial and venous blood. So in the arterial blood, the partial pressure of carbon dioxide is 40 mmHg and the content is 48 ml per deciliter. Now on the venous side, obviously both the figures will be increased. So the partial pressure of carbon dioxide there is 46 mmHg while the content is 52 ml per deciliter. So if I ask you how much carbon dioxide was transported from the tissues into the blood, what will be your answer? So you can very easily see that from the tissues 4 ml of carbon dioxide was transported. Now let's see the exact mechanism of the transport of carbon dioxide. So you know that near the tissues there is a lot of carbon dioxide present. Now let's say that here there is a blood vessel. So let's zoom into one RBC and see what are the reactions taking place inside. So I've zoomed into this RBC and here you have a lot of carbon dioxide. Now the carbon dioxide will enter the RBC, and remember that bicarbonate was the most common form of transport of carbon dioxide. So this is what we're going to see, how it is converted into bicarbonate. So first of all, this carbon dioxide that has entered will react with water. These, with the help of carbonic anhydrase, will form carbonic acid. Now this carbonic acid, again with the help of the same enzyme, which is carbonic anhydrase, will break down into hydrogen ions and HCO3. HCO3 is the bicarbonate. Now what happens to this H+? So these hydrogen ions are very dangerous. We can't just leave them inside the RBCs. These have to be buffered. So these H plus ions go and attach with the hemoglobin, forming HHB. So H is hydrogen ions and HB is hemoglobin. This is how these ions are buffered. Now what happens to the bicarbonate? So there is a special channel which is called as band 3 protein or anion exchanger type 1. So in the extracellular space there is a lot of chloride. With the help of this channel there is an exchange which takes place between the bicarbonate and the chloride ion. So the chloride ion enters the RBC while at the same time bicarbonate leaves the RBC. This is called as chloride shift. So what can we more learn about this chloride shift? So as we saw, it is when bicarbonate exits the cell in exchange for chloride. This is also known by the other name of hamburger effect. Very important. Now this chloride that has entered, this exerts an osmotic tension in the RBCs. This osmotic tension leads to osmosis. So the water will enter inside the cell. Having knowing this, if I ask you, is the size of an RBC in the arterial and venous blood the same? The answer to this is no. The size of the RBCs in the venous blood is a little bit more. And if someone asks you the reason, so you know the answer. It is due to excess water entering due to the hamburger effect. Now let's say that the blood has traveled all the way from the tissues towards the lungs. Now what is going to happen here? So here the oxygen content is very high. Now let's say that there is a blood vessel, and again let's do the same. We'll zoom into one RBC and see what is going on. So here I've zoomed in and we have a lot of oxygen here. Now whatever reactions we just learned, we just have to completely reverse them. So remember the HHB, the hydrogen ions are going to get released from the hemoglobin. So we have free hemoglobin and the H plus ions. Remember our friend anion exchanger? The chloride ions are going to leave through the same channels and the bicarbonate is again going to enter back in. Now this H plus ions and the bicarbonate with the help of carbonic anhydrase will form carbonic acid. This carbonic acid will break down to form carbon dioxide and water. Now during exhalation, this carbon dioxide that is formed will be exhaled out. This is a major mechanism of the transport of carbon dioxide. Now there are two important effects which I should mention here. We have the Bohr's effect and the Haldane effect. I've already talked about the Bohr effect in the oxygen transport video and the oxygen dissociation curve video as well. So make sure to check both of those out. So Bohr's effect tells us about the effect of carbon dioxide and hydrogen ions on the binding of oxygen and hemoglobin. So basically when there is a lot of carbon dioxide and H plus ions, which is seen near the tissues, this will help in releasing the oxygen from the hemoglobin so that the oxygen can go from the RBCs to the tissues. Haldane effect is exactly opposite. It tells us about the effect of oxygen on the carbon dioxide and H plus ions. So just summarizing, in the presence of carbon dioxide and H plus ions, the oxygen dissociates from the hemoglobin and goes to the tissues, and in the Haldane effect, in the presence of oxygen, carbon dioxide dissociates from the hemoglobin and is exhaled out, which is what we just saw. That in the presence of oxygen near the lungs, the whole equation is reversed, leading to the formation of carbon dioxide, which is exhaled out. That's it for this video. If you have any doubts, so please leave them in the comments or feel free to message me on Instagram anytime. The link to my Instagram is in the description. Thank you.